Welcome to my Java tutorial. In this video, I want to explain thread and runnable, volatile, synchronized, and atomic integer. In this first example, we create a thread with thread builder. Have a static class task implements runnable. In the override run, I print task running. A for loop, index from 0 to 5, print index and the index, and sleep 1 second. If everything is finished, task is done. With the thread builder, I create a my thread builder, thread of platform, with the name my thread. I create a thread object from my thread builder, start, new task. So this one. I print thread name is the thread name. I do thread join to wait to finish the thread. And at last, main is done. We run it. You see, task running. Task, my name is thread, index 0 to 5. Task done, main done. In the next example, we use AtomicInteger. I create two tasks, work increment, while counter is less than 10, counter increment and get. Sleep 500 milliseconds. If we have an interruption, worker increment stopped, and return. If everything finished, worker increment done. And thread decrement, this one, interrupt. Worker decrement implements runnable. The run, counter bigger or equal than 0 in the while loop. Counter decrement, sleep 1000 milliseconds. If we have an interruption, worker decrement stopped and return. If everything run finished, worker decrement done and thread increment, this one, interrupt. We go to the main class. Here we have AtomicInteger counter with initial value 0. We create two threads, thread increment and thread decrement. Thread increment is new thread from worker increment. Thread decrement is new thread from worker decrement. Increment start, decrement start. What's gonna happen? We start with counter 0. Here we increment the counter plus 1. And wait 500. Here we decrement the counter, counter minus 1, and sleep 1000. So what's gonna happen? The counter is slowly gonna up because the time here is smaller than the time here. We run it. I move it up, and you see counter increment 0, 1, 0, 1, 2. Slowly gonna up. If the counter is 10, we interrupt the decrement. You see, increment done because we are 10. Decrement stopped and the main class finished working. Example, we create my loop. Inside my loop, we have a for loop from 0 to 3, wait 1000 seconds, done is true. A second method, wait to finish, while done is false. We start with done is false, and for the moment we use a normal boolean, not a volatile. We go to the main class. We create one task, with my loop loop. You have the ID is running. If execute is code, and if the task is done, task with ID is done. Second task is my loop wait to finish. Again, task ID is finished. Now we go to the main. We have number of threads 5. From 0 to 5. Thread, my thread, task 1. This one, thread, new thread, task 2. And we run them both. Want to see what happened? We run it. And you see the tasks are running, the tasks are done, but not finished. Normally we need this line, task finish. That's why, because we use the normal boolean comment. The volatile boolean, done. Now we run it. Again, the tasks are running, the tasks are done and finished. And at the end, the main class is stopped. Here we use volatile. The next example, we use a counter, increment and get, a synchronized version with increment and get, and an AtomicInteger version with increment and get. We go to the main class. First we use the normal counter. I create a task, implements Runnable, print out the name is running, a for loop from 0 to num count is 100,000. Every time we increment the counter. Infinite, its name is done with the counter number. In the main, we create some threads from 1 to 5. So we create 5 threads. Thread, my thread, new task. This one goes inside with the name, task, and the number of threads. Start everything and wait 2 seconds. If everything finished, my counter and my counter get. So here we create 5 threads, and inside the thread we have a loop of 100,000. If everything runs smoothly, at the end the counter has the number of 500,000. We see what happened. I move it up. See, running 2, 4, 5, 3, 1, but at the end we only have 100,000, but not 500,000. We comment the normal counter and we use the synchronized counter. We run it now and we see task 1, 5, 2, 3, 4 running. All the tasks are done, and at the end my counter 500,000. We go to synchronized. You see here the keyword synchronized, and that means synchronized is thread safe. We go again, we comment out this, and we use AtomicInteger. We run it again. See, the task is again running, the tasks are done, and my counter is 500,000. What means synchronized and AtomicInteger both work. Normal counter doesn't work in threads. Why we use AtomicInteger? Because AtomicInteger is not so big on the memory and the CPU power. Synchronized use more power and more memory in this case. This was it for this video. As always, you can find the code on my GitHub account. Don't forget to subscribe and give a thumbs up. Hope you liked the video. See you later.